physics, the study of quantum mechanics is the study of the smallest elements and forces of matter and how they react and interact and thus create all that we know. The word quantum, its plural is quanta, comes from the Latin word quantus, for how much. There seem to be several prevailing schools of thought on what exactly these small elements are. Are they particles? For in some experiments they behave exactly like a particle should. Or are they waves? Because in other experiments, the very same elements behave exactly as a wave should. But how can this be? Waves and particles are two entirely different forms of reality. One school of quantum mechanics thought is that the elements are both wave and particle, or as some describe, packets made up of particles, called wave packets. This is called the particle-wave duality theory of quantum mechanics. We have known about atoms for several hundred years. We know that atoms are the stuff of all that is, both living and non-living. All matter is made up of atoms. It was from our knowledge of atoms and how they interact and react that gave us the technology for atomic bombs and nuclear energy resources. But now we know that an atom is not the smallest thing in the universe of reality. Atoms are made up of even smaller bits, or particles, or wave packets, or substances of reality. And it appears that these elements are made up of even smaller elements and or energy forces. This was first discovered in the early 1900s. We also know that it is electromagnetic force, or some would call it light, that holds electrons and protons together in atoms, and which hold atoms together to make molecules. So, at its most basic level, the atom is held together by light. So we now know that everything is made up of smaller and smaller parts. But we've also discovered that these small parts interact in ways in which we cannot describe by known laws of the universe. Quantum laws appear to be very different from the classical laws of nature. The quantum particles seem to be operating outside of our reality of time and space. We know, for example, that when one of these small parts is manipulated or stimulated in any way, it seems to instantly affect and cause reaction in the other small parts associated with it, which do not otherwise appear to be connected by any force or even connected by yet another small part. It doesn't even matter if these small parts are separated by great distances. They still react instantly to the stimulus applied to another part. It is as though they are tied together by some invisible force or energy, or some would even speculate, some unknown and immeasurable thought or communication process. This phenomena is known as the entanglement theory. This gives rise to the philosophical thought that since everything elemental was created or came into being in one big instant, then everything at the subatomic level is still connected or entangled and somehow reacts together. In addition to these strange phenomena, we have no way of exactly and precisely knowing where and when one of these small parts will be in any particular location or state. We can only speak about their location or state of existence in probabilities. For example, once a quantum state has been prepared for observation, some aspect of it is measured, for example, its position or energy. If the experiment is repeated, however, so as to measure the same aspect of the same quantum state, the result of the measurement will often be different. Some physicists even theorize that it is the very act of measurement or observation itself that causes the results to change. This is known in quantum physics as the measurement problem. Also, it seems apparent thus far, the smaller you go in the observation of these small parts and their interactions, the less and less of anything that we know as real seems to exist. Time and space and matter seem to disappear into nothingness. Philosophically, this is very challenging, since we live in a real world with tangible objects existing in a time-space reality, yet we know that our reality is made up of the very particles which themselves seem to recede into nothingness, and they operate outside of time-space realities and natural laws of our material world. But how can this be? Welcome to just one more of the many conundrums of quantum mechanics. To most people, quantum mechanics is a very strange science. In all other scientific theories, we have tangible models of how we think things work. Quantum mechanics theory only describes how probabilities change with time. If you are confused by all of this, you then are in good company, as many scientists and physicists are on record as stating their confusion by it all. I do not think anyone has a good understanding of exactly what is going on within quantum mechanics, although many physicists are firmly convinced of the correctness of the particular interpretation that they favor. One thing is certain: as much as we do know about our world, our reality, and the universe, apparently there is an infinite universe of information that we do not know. Therefore, we are like ants looking at the moon at night, wishing we could just touch that big, bright, shiny light up above. Even though we as an ant can see it, we don't even remotely understand it or its distance from us, nor the element of space in which it exists. Much less do we have the ability as an ant to touch it. It simply will never happen, but we try and touch it anyway. And that, I am afraid, is our plight in grasping the vastness of information concerning quantum mechanics reality.